and don't expect me to compensate you 8%, but I'm going to compensate you something because it costs you something. It costs you an opportunity. It doesn't have to be an investment. You could have bought yourself a nice little iPhone. You derive personal benefits from it. You gave up on that by giving me that money. So you're entitled to compensation. Economy-wise, if you think about it, let's think about a closed economy. You never do anything with the outside. Whenever somebody lends, somebody else borrows. So the net debt of the society is zero. But the people who lent the money are going to use it, they could have used it to invest in itself. Well, what is that thing that they invest? It's the entire economy. So expected growth rate is essentially a fair interest, assuming there's no default risk. Of course, depending upon who borrows it, we're going to do adjustments. You know, somebody with a credit score of 850 is a lot less likely to default compared to someone with a 550. So you're going to tell them, okay, I would have charged 852%, but I'll charge you 10, 12, 15, whatever the number is. That's why $1 today is not the same as $1 tomorrow. And that has nothing to do with inflation. It's because of the interest. Generically, let's do some notation. We're going to call R period interest rate. When I say period, at this point it's a generic term. It could be a month, it could be a year, 2 decades. T is length or number of periods. Come on. Generically, when I say FVT, this means value after T periods. And when I say PV, which is the same thing as FV0, we're going to call that present value. Value as of now. We're going to develop a simple equation that's going to tell us the relationship between the value now versus value T periods from now. Let's start simple. Let's call T1. And PV is 100. And let's say interest rate is 10%. 1 year from now, interest payment is going to be interest amount PV times R, right? I lent you a certain amount, and you're going to pay me back 10% of that as interest. So in this case, it's going to be $100 times 10%, that's $10. But the value I'm going to get 1 year from now is going to be PV plus interest amount. Or PV plus PV times R. You can collect PV, and this would be PV times 1 plus R. Or alternatively, to kind of help myself, I can write this as FV0 times 1 plus R. Remember, FV0 is the same thing as present value. So in this case, it's going to be 100 times 1 plus 10%. Not that I'm going to ask you to ever remember this. Not a bad idea to be able to convert a percentage into decimal. But when you're using Excel, you're not going to need that skill. Or I call it parlor trick. 110. At the interest rate of 10%, if I lend you $100 now, I expect to get 110. You know, if you don't pay me back, you'll probably find the horse is saving okay. I'm a big Godfather fan. And you'll hear me make a lot of movie references. Now I want to know, okay, I lent you that money, and 1 year from now you told me, how about I keep this money a little more? Sure. This time, it's as if you owe me now 110, I'm going to charge interest on that. Okay. If you notice here, the equation is by one period. So if I want FV2, all I have to do is shift those by one period. Whatever the value was at the end of period 1, I'm going to multiply that by 1 plus R. And since I already know that, I can write it. 110 times 1 plus 0.10, and that's going to be 121. That extra $1 is interest on interest. But alternatively, I can do this algebraically. I know the equation for FV1. That's FV0 times 1 plus R, then times 1 plus R. Well, if I'm multiplying something by itself, I'm raising it to power 2. So that's going to be if you continue in this vein, whatever that t is, this is kind of the equation of motion for money. Over time, how do you figure out what your money will be worth if it's invested at a certain interest rate for a certain period of time? So if I say, okay, how about if I give you $100, I'm going to let you keep it for 10 years, and every year I'm going to charge you 12%. How do I figure out how much do you owe me at the end of 10 years? Well, FV10 is going to be PV times 1 plus R to the power T, which is $100 times 1 plus 0.12 raised to the power 10. We're going to normally use Excel, but turns out OneNote actually can make calculations as well. Times 1 plus, you can actually write it as 12% raised to the power 10, so equals that. So you would have to pay me $310.58 10 years from now. That's good. Now, if I change R and if I change T, I can use the same equation to make calculations. The trouble is, this is also an issue with actual financial calculators. Every time the inputs change, you have to go through the motion of getting that answer again. For example, in financial calculators, you basically enter 4 things or 3 things, then you hit calculate, it tells you. That means every time, even if I change only one of the things, I have to enter the other 3 as well to calculate. That's a lot of work. For example, I want to know what if at 1% I want to keep it for 100 years. PV is 100. I'm going to be smart. I'm going to copy this, paste it. $270.48. But this time I'm keeping it for 100 years, but as long as there's a better way of doing things. It's called Excel. Now, first let me set this up. Let's call this present value of single flow. I'm sorry, I meant to say future value. Okay, $100. I'm gonna make that dollar format. Under Home tab, there's this piece. Oops. Number of periods 10, and period rate. Interest rates are expressed in percentages. Internally speaking, Excel doesn't care whether you format it as a percent or a number. Internally, 10% is 0.1. But to make it easier on us, format that as percent, and I typically use 3 digits, 3 decimals after the point. This left arrow increases the number of decimals that is shown. Now, to write 10%, all I have to do is write 10. I don't have to remember that it's 0.1. Or 0.5%, 0.5%.